Hello friends, Namaskar. In this lecture today, we will discuss about the technologies for making powders and premixes, and these powders and premixes will be studied in two parts. In the part 1, we will discuss the basic concept of fruits and vegetable powders and premix preparations, then methods and equipment for powder and premix development, the drying process like spray drying, freeze drying, roller and drum drying or belt drying will be basically discussed here, and then towards the end we will also discuss something about food premixes. Okay. Food powders, that is many a times, as we have seen in the earlier class, okay, where we were discussing drying and dehydration, where the juices, fruit juices and fruit pulp etc., these are basically in the liquid state, or even sometime the materials which are in the dried state, like you can say that dehydrated fruits etc., maybe in the form of thin or thick slices etc. So, both either the solid food material or the material may be in the liquid state, they can be converted, they are generally converted into powder using one or the other technology, and this is just to have ease of its use, in ease of its processing and for keeping quality. Okay. So, the powders are particulate solid state materials containing discrete particles of sizes ranging from nanometers to millimeters. Various terms are used to indicate the particulate solids in bulk, such as powders, granules, flour and dust. All these, although they are in the particles of various sizes etc., on the basis of their sizes they are named as either powder or granule or flour or dust. Granular products have a dimension of the order of millimeter, while fine powders products are of the average size less than 100 micron. The bulk powder properties are the combined effect of the particle properties. Okay. So, the methods which can be used generally to prepare powders, particularly fruits and vegetable powders, that is, as I told you, the material may be in the liquid or paste form like juice, pulp, concentrate, paste, puri etc. So, for this spray drying, freeze drying, drum drying or belt drying or foam mat drying etc., can be used to convert them into the free flowing powder form. The other maybe the material might be in the solid state, in the like the dehydrated fruits, dehydrated vegetables, spices etc. So, for them they can be converted size reduction, appropriate size reduction technology, that is by crushing, grinding, milling, pulverization, then finally granulation and mixing. So, these are the processes used for the preparation of powders. So, let us see one by one, we will take up the major technologies, and the first we will take up the spray drying technology. It is a very popular method being used for the conversion of liquids into free flowing powders. So, in the spray drying, as you can see here in this, there is a drying chamber, okay, and there are certain atomizers, okay, and with the help of these atomizers this liquid is fed into the fine droplets, and the drying chamber hot air comes in. So, in this chamber the fine droplets come in contact with the hot air, and where the air is, that is material gets dried. Then moist air, that air which absorbs the moisture, moist air goes through the cyclone and it is good, and the product, the dried product is collected from the bottom of the spray dryer. So, there are basically three fundamental steps in spray drying, that is atomization, then mixing of the spray droplet with the heated hot gas stream, allowing the liquid to evaporate and leave the dried solids, and finally separating the dried powder from the gas stream and collection of the powder. These are the important. Okay. Atomization, as I told you, that is the prime function of the atomization here a high surface to mass ratio resulting in high evaporation rate and production of particles of the desired shape, size and that density. Okay. So, there are three basic types of atomizers which are used commercially. One is the rotary atomizer. You can see here in the schematic figure, the fluid goes through this. It uses the energy of a high speed rotating wheel to divide bulk liquid into fine droplets. Feedstock is introduced at the center of the wheel and it flows over and disintegrates into droplets when it leaves the wheel. So, that is fine droplets. Then other atomizer is the pressure nozzle, atomization by pressure energy. So, you can see here in the figure, that is the liquid passes through a nozzle, that is the rotating fluid allows the nozzle to convert the potential energy of the liquid under pressure into kinetic energy at the orifice here. Okay, and it forms a thin high speed film at the exit of the nozzle, and the range varies from around 250 to 10,000 psi pressure. Okay. Then two fluid nozzle system, that is here it is basically the principle is the atomization by kinetic energy. You can see here in the schematic figure, it utilizes the energy of the compressed gas to atomize the liquid and has the ability to produce very fine particles and to atomize highly viscous fluid. That is, if this is a thick paste concentrate etc., they can be also suitably atomized using two fluid nozzles. Then after the atomized, as I told you earlier, in the drying chamber, then mixing, there is mixing of the hot air with the fine particles, okay, on the liquid. It must be brought into the intimate contact with the heated gas, heated air for evaporation from the surface of all droplets within the drying chamber. So, the heated gas is introduced into the chamber by an air dispenser. You can see it is drying gas, okay, and which ensures that the gas flow equals to all parts of the drying chamber. That is, so that the drying chamber must be of adequate volume to provide enough contact time between the atomized cloud and the heated glass. And this is here particularly for fruits, when vegetable juices drying etc. That is here because of that there may be conventional spray dryer which is used for milk drying etc. does not suit, is not suitable for the liquid drying, because that is the in the conventional drying the drying time is in the fraction of minutes, that is a few seconds, and that is a so it goes, the temperature has to be, in order to cause the complete evaporation, temperature has to be very high in the drying chamber. Okay. But it is it cannot be done in the fruits and vegetable juices, particularly the sugar containing juices. They are heat sensitive, they are Tg value, glass transition temperature value is less. So, even the material that is cannot be heated, if it goes beyond a certain temperature, beyond it's the material of the drying, it goes above its Tg, then it will introduce stickiness in the product will become sticky, and its removal from the drying chamber will become difficult. So, a suitable modification may be the drying chamber for such either has to be very high towers etc., or some other arrangements which I will discuss little later. That is then comes the powder separation. Okay. That is it from the bottom, that is this basically the spread, as you can see here, that is bottom is made into the conical shape, so that the removal of the product becomes easy. Okay. When the coarse powder is to be collected, they are usually discharged directly from the bottom of the cone through a suitable airlock like rotary valve etc. Okay. The gas system having the evaporated moisture is drawn from the center of the cone above the cone bottom and discharged through a side outlet which acts as cyclone. Okay. So, this must be separated in the high efficiency cyclones, followed by a wet scrubber in a fabric filter. Okay. The fines are collected in the dry state, they are sent to the larger powder stream or even recycled. Okay. So, there are, you can see that is there are different types of spray dryer system, that is depending upon that is whether that is you are giving the into fine droplets and air. That is, if you can see here in this, if the air entry of the air, hot air as well as the feed, if it is in the same direction, it becomes a co-current. So, spray evaporation is rapid and the temperature of the drying air is quickly reduced by the vaporization of the water in this type of system. In the counter current system, you can see here air is going from the bottom to the top, from it is air is introduced at the bottom and the feed is introduced from the top. So, it is a counter current system. Okay. It is more rapid evaporation is there, higher efficiency, energy efficiency than a co-current design. However, it is not suitable for heat sensitive products like fruits and vegetable drying, etc. Mixed mode is combined both the co-current as well as counter current flow. The air enters at the top and the atomizer is located at the bottom. It is also not suitable for the heat sensitive products. So, in nutshell we can say for fruits and vegetable dehydration, the co-current system may be better. Okay. Then as I told you that in the spray drying, because of the fruits and vegetable, they contain monosaccharides, sugars, heat sensitive components. So, a suitable that is the changes that is has to be done in the dryer design, or this spray drying can be combined with other systems to have the better efficiency. Okay. So, that is one is the have a very high drying tower, or that is dehumidified air is used, or even ultrasound assisted spray drying. It uses ultrasonic atomization for generating the spray droplets. Ultrasonic nozzles, atomizers are electromechanical devices that vibrate at a high energy to induce droplet formation. Okay. The vibration energy applied to the atomizing surface it spreads onto the surface as the liquid passes through it, and this leads to the formation of a thin film at the top of the atomizer. And as this film absorbs the vibrational energy, capillary waves develop in the and break down into small droplets once their amplitude reaches a critical height. So, the main atomization parameters are vibration frequency, vibration amplitude and area of the vibrating surface, and these are adjusted according to the characteristics of the feed material. Then vacuum spray drying, it is another, that is the drying is performed under vacuum with the use of low drying temperature like 40 to 60 degrees Celsius, and it is advantageous for the heat sensitive material. As I told you, for fruits and vegetable, in many cases fruits and vegetable they contain monosaccharides, low melting points, and this low Tg value about 50-50. So, their temperature is maintained below that. So, the superheated steam acts both as a heat source and drying medium, and it is supplied at 200 degrees Celsius to spray drying chamber through a steam nozzle, and most of the superheated steam is recirculated and reheated. The excess of steam from the drying process can be used elsewhere in the process or plant. Then and the dehumidified air spray drying, that is dehumidified air is used as the drying medium. Dehumidified air is produced by an air dehumidifying system connected to the drying chamber. So, low moisture content and relative humidity of the air improves the driving force for drying even at a lower temperature. So, one can get the drying at a lower temperature. Spray drying with the dehumidified air substantially alleviate the stickiness problem. It removes the stickiness problems and improves the powder recovery compared to the traditional spray drying. So, the powder also has a power a lower residual moisture content, higher bulk density and particles with a smooth surface. So, these are the about. Then obviously, the factors affecting the spray dried products, okay, that is main factors, that is the feed characteristics like its composition, density, viscosity, glass transition temperature, heat sensitivity, addition of drying aids etc., or operating conditions of the spray dryer like atomizer speed, inlet outlet temperature, drying air flow rate, feed flow rate, feed temperature, residence time, humidity of the drying air etc., and then spray dryer design like other flow type like co-current, counter current, mixed flow, or atomizer type like centrifugal atomizer, pressure atomizer, pneumatic atomizer. So, depending upon the material, its characteristics etc., one has to properly select all these parameters, control the proper parameters and do the drying to get the product better quality. Okay. So, here a comparison has been shown that at the top you have the spray dried powder which is given with the only that with the inulin or maltodextrin or a mixture of inulin and maltodextrin, and its comparison with the freeze dried powder and the vacuum dried powder, vacuum drying at 50 degrees, 70 degree and 90 degree, and you can see here the particularly the color etc., it is a very good, it is a encapsulated sea buckthorn juice powder. Okay. So, the key properties of the powder obviously are the uniform particle size, spherical particle shape, excellent flowability, improved compressibility, low bulk density, better solubility, reduced moisture content, increased thermal stability, and even that if properly controlled, there should be least loss of the nutrients. If high temperature, there will be some losses. Then next is freeze drying. Obviously, it is it is an ideal method for drying of heat sensitive materials. So, for fruits, vegetable juices etc., even the instant coffee etc., this is the freeze drying process is used. So, here it is the freeze drying like sublimation. So, in the freeze drying, material is first frozen and then the ice or water in the ice form is sublimed directly, that is a so it is a triple point. So, you can see if this triple point is maintained, then the directly solid can be removed in the form of a gas. So, the freeze drying occurs in two stages, one in the sublimation drying stage, in which the sublimation of the frozen water like ice crystals occurs normally. Most of the water in the food is removed at this stage. Then also there is a second stage, the desorption drying stage, where water absorbed on the solid matrix is removed. So, freeze drying is carried to a final moisture content of about up to 1 to 3%. Okay. And the rate of the freezing, and I think about freezing we have already discussed in the earlier lectures. So, rate of the freezing affect the quality of the freeze dried product. Okay, as well as rate of the drying process. Rapid freezing produces small ice crystals which do little damage to the structure of the product, but they leave behind very small pores and capillaries and offer a greater resistance to the passage of the vapor. Whereas the slow freezer, it produces large crystals and they make rapid drying possible, but the large crystals damage the cells, produces separation and denaturation of the proteins etc. So, upon the rehydration there may be some changes in the structural materials. So, if you look at the heat and mass transfer in the freeze drying, that is heat can be delivered to the subliming plant by two most common mechanisms. One is the radiation from the hot surfaces, okay, that is where heat is delivered to the exposed surface of the dry zone by radiation and then travel through the dry zone to the sublimation plant mainly by conduction, as you can see in this first figure. Okay. Then the water vapor released travel through the dry zone in the opposite direction from the sublimation plant to the surface and then from there to the condenser. Then second way of the heat transfer is the contact with a hot surface. The material frozen mass is it is a direct contact with a hot surface, you can see in the second figure. So, the trays containing the frozen material are placed on the heated shelves, heat is transferred to the sublimation zone by conduction through the frozen layer, and water vapor is transferred through the dry layer. Okay. The heat and mass transfer, that is here, assume that an incremental thickness dz of the slab is dried at a time increment of dt, small t, that is here it is shown in the figure. Okay, there is a frozen layer, dry layer, heat is supplied, and from the frozen layer vapor directly ice in the vapor form, it goes out, and the layer is z here is the thickness. Okay. So, the rate of the sublimation, that is dw by dt, is equal to A rho I wi minus wf dz by dt, where A is the slab surface area of the slab subliming surface area, rho I is the density of the frozen food, and wi and wf are the initial and final water content respectively. So, at a steady state, the rate of sublimation must be in accordance with both with the rate of the heat transfer to the sublimation plant and with the rate of mass transfer from the sublimation plant. Okay. So, the heat transfer, like conductive heat transport from the slab surface to the sublimation plant through the dry layer, that is Q is equal to A k T0 minus Ti by Z, where Q is the rate of heat supply, K is the thermal conductivity of dry layer, and the T0 and Ti are the temperature at the slab surface at the sublimation plant. So, the rate of heat supply, like Q, is equal to the rate of sublimation multiplied by latent heat of sublimation, and which is accordingly this equation is 3. Okay. Integrating equation 3 within the limits z is equal to from 0 to z and t from 0 to t, the drying time t can be obtained as t is equal to z square wi by minus wf by 2 t0 minus ti rho I lambda s by k. So, this is the steady state condition. Drying time one can calculate using this figure. If you see the mass transfer, that is a steady state, the rate of sublimation must equal to the rate of removal of vapors by mass transfer through the dry layer, and this, well, that is the equation 4, it is expressed. Okay. So, integrating equation 4 within the limits z is equal to 0 to z and t from 0 to t, the drying time t can be obtained from the t is equal to z square wi minus wf divided by 2 pi minus p0 rho I by pi, where pi is the permeability of the dry layer to water vapor, and pi and p0 are the water vapor pressure at the sublimation plant and at the slab surface. So, using this equation you can calculate the drying time. Here in this there is a case study, freeze dried from pomegranate powder, where this fresh material pomegranate is taken, converted into the juice, and it is concentrated, and this concentrated, that is it is put into the freeze dryer, and it is dried. The flax it is then in the form of thick snake, and it is further pulverized, and it is, so there are freezing at minus 30 degrees Celsius, then under the low pressure, once if it is heated, ice evaporates, and then the water is added to a dry product, it is restored to its original condition, rehydration, to get the again to drink it. So, the advantages here are that minimum damage and loss of the activity in the heat labile materials, there is a creation of pores, it is a friable structure we get, and it is speed and completeness of the rehydration, that is freeze dried material, they very quickly rehydrate, better rehydration characteristics. However, the major disadvantage is because it is a very high capital cost of the equipment, high energy cost, it is a lengthy process time, and possible damage to the product, particularly in the freezing etc., it is not properly conducted. So, in the some of the structural damage may be there otherwise there is no heat. So the very quality is very, and it is normally used because of the cost problems. It is the very heat sensitive materials, and high value commodities are used for this heat freeze drying. Then the roller and drum drying, the product may be placed in its natural form. Here there is a drum. Okay, so these drums are internally heated. It may be single drum, twin drum, three drum, etc. So these material, freeze tray material of the pit tray of suitable consistency is put, and the drums moves. Okay, and then it takes the material, and the drum is internally heated. So heat transfer takes place, and finally there is a doctor blade. So the dried material, it scrapes out and is taken as a conveyor belt, and the product is pulverized. So in some vacuum units, the product is accumulated in a tub or tray and then removed periodically, first from one side of the enclosed chamber, okay, to the other side, while maintaining a vacuum on the drying unit, because by maintaining the vacuum, drying efficiency can be improved, and again otherwise the removal of the products and even hygroscopicity, etc., all those problems can be taken. The air in the whole drum dryer and particularly these belt, etc., this should be maintained in low humid areas and low temperature area. So a hood must be placed over the drums with a stack of vapors to move out of the area. So the factors which should be considered for the vacuum drum drying is the vacuum level. Okay, for vacuum drum drying, the vacuum between the drum and the housing surrounding the drum is maintained between 69 to 74 centimeter of mercury vacuum. The product temperature approaches the temperature of the steam heating medium. Okay, and so basically here in the case of vacuum, the inside of the drum is heated with the steam with a low pressure. Then size and speed, the drum size, diameter of the drum may be up to 61 to 122 centimeter, and length may be up to 3.6 meter or so. Speed may be from 6 to 24 RPM. However, it is adjustable. It has to be adjusted depending upon the material characteristics. Okay. Then speed of the drum is an important factor, as it affects the thickness of the film as well as the time the product is on the roll. So the speed of the drum may be varied according to the concentration of the product and the dryness desired. Okay. Then product contact, that is the uniform film feeding, mounting, that is the one drum of a double drum dryer is mounted on a stationary bearing. The outer drum is mounted on a bearing which can be moved to provide the desired clearance between the drum, and then spacing with the drums of a double cylinder dryer is about 0.05 to 0.1 centimeter, where the drums are cooled, etc. So these are, and also very important is the uniform film feeding, that is the consistency of the material and at the speed at which the drum rotates, so that there is a uniformly spread on the drum, that is the feeding. The concentrated product is fed onto the drum next to the spreader rolls. Okay. So the factors which influence are affecting the production from a drum dryer is called the feed temperature, drum gap, drum speed, and steam pressure, etc. As in the case of every time, that is the, if the feed temperature is high, then the drying rate will be high. But because of that, we are discussing especially for fruits, vegetables, and such other commodities which have heat sensitive material. So that's why vacuum drum drying we are discussing, so that the temperature is not increases very high. That is the rate of drying increases proportionality at about 2.2% for each 5.5 degrees Celsius increase in the feed temperature. Okay. Similarly, the clearance between the gap, speed at which the drum rotates, steam pressure, all these influence. Then the advantages and disadvantages of the drum drying, that is the advantages are the drum drying along with the spray drying has many advantages, including minimal energy consumption, residence and dispersion. Drum dryers are also capable of generating exclusive powder properties, further enhancing their applicability, etc. However, there is disadvantage that dry product may have a scorched flavor and solubility in much lower because of the protein denaturation. Product damage due to heating occurs. Okay. So, the product may be damaged and scorched if there is uneven heat supply, incomplete removal of film, or imperfect roller alignment, etc. Okay. Then the belt drying we have earlier discussed about hot air drying. So, similarly here are the conveyor belt where the food material of a suitable consistency belt, and the belt is like a foam bed drying we have discussed. So, this foam that is the thinly it is spread on this belt and then hot air drying. Okay. So, in the belt dryer it comprises a feed hopper, evacuated chamber, there is a belt, and particularly the belt material it should be because the Teflon coated, etc. So, that it is a non-sticky material. The material does not stick it removal of the dried material can. Then heaters, a radiation plate 23 centimeter wide and 100 centimeter long was located above the belt and spanned the length of the conduction heating plates, and then a vacuum pump which maintains the desired pressure inside the system. Okay. Here is a case study. It is shown that the manufacture of the strawberry powder and this the crushing, washing, etc., and then unwanted and bad quality material is or then juice is prepared, juice is concentrated, and it is either spray drying or freeze drying there, and final powder is spread, that powder or freeze dried powder is prepared and it is packaged suitably. Then we come to the premixes, that is the we have prepared one powder of a one fruit or one vegetable. Then normally in the market nowadays various premixes, even the soup powder, tomato soup powder, such other soup powders, etc. So, where the different food powders or ingredients are mixed together in a specific proportion. Okay. And then we get the powder or in the premix powder form. It is generally customized blend of nutrient rich powders in precise quantity as per the requirement. It reduces food processing, sourcing time, okay, storage space and handling procedures during the specification of the finished products. Okay. And then you can have a direct ready to consume form of these powders, etc. Okay. So, normally there is a technique of the formulation. Formulation can be optimized using mathematical models to find best solution with respect to the some evaluation criteria from a set of the alternative solutions, and these solutions are defined by a set of mathematical constraints, maybe mathematical inequality or mathematical equalities, etc. Okay. And there are several mathematical models which are available, which are proposed, which can be in such on the linear programming model is one. If the linear programs are constraint optimization models that satisfy three requirements. One is that the decision variables must be continuous, they can take on any value within the some restricted range, the objective function must be a linear function, and the left hand side of the constant must be linear functions. So, you can see that is we here minimize or maximize any particular value z, okay, subject to z is equal to c1 x1 plus c2 x2 plus cn xn, subject to that is various parameters like a11 x1 plus a12 x2 plus a1n xn may be equal to, less than, or more than, higher than b1. Similarly, a21 x1, a22 x2, a2n x1 may be equal to, higher or less than b2, and so on. So, this xi are values of the decision variables, and cj, aij and bi values are constant. This is called parameters or coefficients that are given or specified by the problem assumption. So, most linear programs require non-negative decision variables. So, this is one model we can use. So, by this you can have different components in desired quantities. For example, suppose you want to have a particular premix which should have protein content this much, this vitamin A, vitamin B and salt, sugar in particular proportion. So, accordingly, and you have the feed, that is input, there are 3 or 4 inputs. So, in which proportion you give the input characteristics, you give your constraint, define your objective functions, okay, and then the problem, it will give you the problem. Yes, there are 4, 5 x, x1, x2, x3, x4, you prepare, take this in this proportion, mix it, you will get the desired value y or z. Okay. So, obviously, the steps in this case are here: identify and define the decision variable for the problem, define the objective function, and finally, identify and express mathematically all the relevant constants. Okay. And implement implicit assumptions may be proportionality to the contribution of the individual variable, as I told you, in the objective function is proportional to their value. Additivity, the total value of the objective function, and each constant is the sum of individual contribution from each variable. Divisibility, that is the decision variable can take on any real numerical values within a specified range, and finally certainty, that is the parameters are known. So, these things are, you give the desired input and get the required parameters, required output. So, this is that is the today's class we discussed the different methods of making powders, and particularly fruits and vegetable juice powder, fruits and vegetable pulp powder, as they contain heat sensitive components, low that is the low Tg values, they have contain low melting components. So, they cannot be, or rather they should not be subjected to very high temperature in the drying process, otherwise there will be, whether it is spray drying or it is drum drying or belt drying, it will create a problem of stickiness, etc. So, the proper care has to be taken in the spray drying, suitable design arrangement are taken, or one has to go with the pressure, lower pressure vacuum spray drying or vacuum freeze drying, etc. Okay, or even, and then when the powder are obtained, these powder using appropriate formulation techniques, they can be blended together in a definite proportion in order to get the desired, and this is used for preparation of various soup premixes, various ready to serve vegetables, juices, etc. They are available in the market and they can be prepared, they are prepared using these techniques. So, this is the references used in this lecture. With this, thank you very much for your patience here.